A deadly shopping mall collapse in northern Ontario was summed up today with strong words, among them apathy, neglect, incompetence, greed, and duplicity. 2 people died in Elliott Lake, Ontario 2 years ago when the rooftop parking lot caved in. Joanna Remiliotis has more on today's scathing judicial inquiry report.
There is so little by way of comfort and only some to be found here. A memorial for the victims of a senseless tragedy. One of them was their daughter. Rachel and Regin Aylwin have yet to find peace. They've come here simply to find answers.
Well, I feel it brings back a lot of memories. That's it.
It was so sudden, the partial collapse of the city's mall roof 2 years ago, triggering an exhaustive public inquiry and now a scathing report. A rusted steel beam was the obvious cause of the collapse, but the report found the most damning culprit was the staggering neglect behind it.
They ranged from apathy to outright greed, obfuscation, and duplicity.
The inquiry revealed shoddy construction meant the mall's roof began leaking as soon as it was built in 1979. That despite repeated complaints and obvious decay, inspectors, public officials and owners, including the most recent owner, Bob Nazarian, ignored calls for proper repairs and did little more than patchwork.
No finger to be pointed, especially at the owner.
The controversial rescue operation that was abruptly called off and then resumed was also examined. The report found 74-year-old Dolores Perizzolo died instantly, but that 37-year-old Lucy Aylwin may have survived for up to 39 hours. Miscommunication between emergency crews and delays in getting the right equipment may have hampered her rescue.
It is probable, although by no means certain, that she lived and might have been found alive had the rescue effort been executed more rapidly and more effectively.
To the Aylwins, it's one more horrible what if.
I hope she didn't suffer for 39 hours.
And it doesn't change anything.
The first cause of the collapse is the obvious rust in many of these cases. And it was a real tragedy, and you were only 8 years old, thereabouts, and so it's already history to you, but it's quite recent to me. And the main culprit was deciding to save space by putting a parking on the roof, and this led to the corrosion of the building underneath. It was untried for a reason, and the engineer never should have agreed to this design. It seems so detached from reality, much of what we do in the schoolroom, but the implications of some of our chemical experiments lead to knowledge that should have prevented this building from being built in the first place. And when science and business collide, business tends to have more money and gets its way. This is not the first time this kind of destruction has occurred due to the properties of iron that we don't like, that it rusts. I'm going to take you on a small tour of the corrosion process that makes iron really rather unsuitable for many of the building processes we have been doing for thousands of years. But the problem has been there's little else we can do. And so this would be a billion-dollar solution to find a way around using iron inside our buildings to reinforce it. If you don't use rebar inside a building, which is called reinforcing bar, the concrete, you might as well stack mud. It'll crumble to pieces. So you have to put steel skeleton inside the concrete. Unfortunately, the iron rusts, and concrete is highly chemically active and it tends to soak up water. So how many buildings have you walked by to see the cement surface fracturing like this and exposing the metal bar underneath? And this is what caused the mall to collapse. And so a lot of chemists and engineers have been working to figure out means of stopping this undesirable property of iron. And you can get as fancy as you want. This equation going on in here showing how the rebar is chemically attacked is something chemical engineers and building engineers would look at to try to solve. And they know the entire process, it's to eliminate it, would save lives and make our buildings last a lot longer. So this would be about grade 12 chemistry if you got that far. But you can see evidence of iron's unsuitability. But the whole thing is, we don't have anything better to reinforce our buildings with. Sure, you could switch to stainless steel and titanium. That would be fantastic. But for a non-chemical reason, the cost makes it impossible to do. So rebar corrosion may not sound very romantic, but people die if it fails in a big way. And you can find this everywhere on the planet. Malls collapsing, buildings collapsing, and there's more to a building's structure than just the rebar, but it is one of the well-known failures in our construction industry, and this is what limits the lifespan of bridges and buildings made with concrete and is a real problem in dams. Now, this rebar here does not look like iron, does it? This one here says galvanized. And what galvanized means, you've probably heard of galvanized buckets, is you've coated it with zinc. And if you get a nail that's zinc coated, so zinc has a almost a chrome-like look to it, but it's dull. You can't put a shine on zinc. So this is a galvanized surface, okay? And different appearances to galvanized. It's a silvery to a bluish coating, okay? Here's an example of a galvanized rebar being tied to a standard iron one, and you can see the galvanized one is working really well. And here's an example of the standard rebar partially coated and a fully galvanized one exposed to the elements. So why haven't we moved to 100% galvanized rebar? Again, the cost, and you run into another problem. You see here, low-end construction, and the engineers decide this. They wire tie the rebar together. But if you've ever gone by a building that's being assembled, you will often see welders on work on the rebar. So in other situations, they may weld the rebar together. And at that point, the zinc is not only useless, it's actually hazardous because you'll burn the zinc coating off when you weld. So the money you spent putting this coating on here will be gone. But the other problem is you must not expose zinc to flame. If you ever had this zinc coated rebar and you were working a summer job on construction and the guy said, cut it up with a torch, you refuse. When zinc is incinerated in flame, the zinc fumes will come off and poison you quite rapidly. It's very easy to kill yourself by only burning the zinc off a couple of feet of this rebar, and you will die within a few days. They call it zinc fever, and it's not as well known in the amateur DIY stuff. So here's an example how quickly you can find where we can't find the material with a suitable property. So why have we not mandated zinc go in everything? All you have to do is scratch that zinc surface and you introduce an opening and it rusts. So the zinc rebars work really well in the lab, but they are more delicate because you can scrape the coating off. So then the cat daddy would be a bar that is somehow corrosion resistant all the way through, is strong as iron, and a non-chemical justification would be, is it economically feasible? But that is not a chemistry example. I'm going to introduce you to something else here. And you might go, why didn't I just put this as reading? Because sometimes this is nicer. It would be something closer to what I did in the classroom. If we look up galvanic corrosion, I'm sure you've seen this. And I would like you to read this Wikipedia page. Doesn't mean memorize it, doesn't mean you're going to be studying it, but this is the closest I can bring this stuff real without our classroom. In the classroom, I could show you this stuff. I could pass around things that you could handle. So this is my attempt of replacing the show and tell in the labs, is to kind of tour you through things. So galvanic corrosion occurs when you attach two metals that are not the same together. So you can read this and you might go, wow, this is a lot to read. No, not really. It'd take you a few minutes to read through it. But this is what you got to watch for. Here's an example of what the kind of corrosion we're talking about, where this metal here, this beam, and these bolts are made out of two different metals, and they're triggering corrosion between each other. They call it galvanic because it's basically acting like a battery. And what happens over time is you get this is not concrete, these are two metal objects, okay? And you can see this corrosion occurring. And not to be paranoid, but whenever I take my girls, they're older now, but when they were babies and we drove them out to British Columbia, at every hotel that had a wave pool, a slide or something, the first thing I would do is look at the bolts on the base. It's not to be neurotic. It's to be abundance of caution. And the old mall in Orangeville, the original light posts were sticking up on concrete pillars, and the bolts were very rusted. And I tended to avoid parking near those light standards because I figured they'd fall down one day. Well, then a few years ago, they completely replaced those light posts. If you pay attention, you will probably on the media hear of a building, a slide, a water park, something collapse over the summer, and it's a failure to inspect these bolts. When I've gone to Canada's Wonderland a few times, same thing. I tend to look at the bolts at the base of the towers to go, is anyone inspecting these things and making sure they work? Now, what's really cool here is this. Here's a little bit of trivia for your parents, is read this section on lasagna cell. And you may have seen it in your fridge, you just made no note of it. So anyway, this is an example where we can have a property that we don't desire. Now this is a chemical property of iron I've been covering, and I'm doing it in physical properties because the two kind of merge over a little bit.